Good morning to all of you. In previous sessions, we discussed two properties of Z transform, that is linearity and time shifting. We also solved some numerical on those properties. So in today's session, we'll be discussing one more property, that is scaling in the Z domain. Okay. So scaling in the Z domain. Okay. So again, if x of n has the Z transform capital X of Z, okay, and with ROC, that is R1 less than mod Z less than R2, right? So this R1 R2 may be any values. Then if I'm scaling this discrete time signal X of n with scaling factor e to the power n, so it will have the Z transform capital X of A inverse Z. Okay, so that means simply I am replacing the value Z with A inverse Z. Okay, so this scaled version of x of n, that is a to the power n x of n, has the Z transform x of A inverse Z, and its ROC will be simply A R1 less than mod Z less than A R2, because in place of Z I am substituting A inverse Z, so I am substituting A inverse Z and I am sending A on left and right side, so it will be R1 upon A inverse, sorry, R1 upon, that is A inverse, as well as R2 upon A inverse. So in place of Z I am substituting A inverse Z, right? So if I'm taking it numerical, so it will be AR1 and AR2, right? So where this small a is a constant, so it can be a real or complex constant. Okay, so the property is called as what? Scaling in the Z domain. Okay, so this Z has been again scaled with A inverse. Okay, so Z has been scaled with A inverse if you are multiplying this x of n with a to the power n in the discrete time domain. Okay, so in time domain you are multiplying discrete time signal a to the power n, so its Z transform will get scaled by A inverse in the Z domain, right? So we'll try to prove this property. Okay, we'll try to prove this property. So we know that the Z transform of x of n is indicated as simply capital X of Z, correct? And it is given as summation n is equals to minus infinity to infinity x of n into z to the power minus n. Okay, so this ROC of x of n is given here is R1 less than mod z less than R2. So we are interested in identifying the Z transform of e to the power n into x of n. Okay, so the formula for this will be n is equals to minus infinity to infinity. So in place of x of n, value is e to the power n into x of n. Okay, so into z to the power n minus n will be as it is. So here you can take this n is equals to minus infinity to infinity, this a to the power n z to the power minus n. Okay, so from these two values, so you will keep x of n. From here you can take minus n common, so in bracket you will get a inverse z to the power minus n. Okay, correct. So if you compare this formula with this one, okay, so in place of z there is value a inverse z, the rest of the things are same, that is the summation limits are from minus infinity to infinity, x of n is there, simply in place of z there is value a inverse z, even this minus n is as it is, right? So this is the formula for what? X of z. So this will be for what? X of A inverse Z. Okay, because in place of Z there is value A inverse Z, right? So initially it was having the ROC. What ROC it has? R1 less than mod Z less than R2. Now here the ROC will be what? R1 less than A inverse Z less than R2, and if I'm shifting this A inverse on left and right side, then it will be simply what? A R1 less than mod Z less than A R2, right? So this will be modified ROC of what? X of A inverse Z, right? And this is the proof of it. Okay, how this comes to X of A inverse Z. So we'll try to solve one example here. So you have to determine the Z transform of these given signals. Okay, so two different problems are there. So in first problem, the given discrete time signal x of n is equals to e to the power n cos omega 0 n into u of n. Okay, so here this signal, that is cos omega 0 n into u of n, has been multiplied with e to the power n. In a linear property, we have already solved this example, that is cos omega 0 n into u of n. We identified its Z transform. Okay, so initially here also we will be identifying the Z transform of this cos omega 0 n into u of n, and then as per the scaling in the Z domain property, we can directly identify the Z transform of a to the power n into this signal. Okay, so in the Z transform you have to replace the Z with A inverse Z value, right? So initially we will identify the Z transform of cos omega 0 n into u of n. Okay, so it will be given as what, or denoted as Z transform of cos omega 0 n into u of n. So it will be simply summation n is equals to minus infinity to infinity cos omega 0 n into u of n into z to the power minus n. But in linearity property, while solving this example, we have seen the Euler's identity. So in place of cos omega 0 n, we can substitute 1 by 2 e to the power j omega 0 n plus e to the power minus j omega 0 n, because e to the power j omega 0 n is nothing but cos omega 0 n plus j sin omega 0 n, right? E to the power minus j omega 0 n is nothing but cos omega 0 n minus j sin omega 0 n. So this sin omega 0 n minus j sin omega 0 n will be 0, and cos omega 0 n plus cos omega 0 n will be twice cos omega 0 n. So 2 will get cancelled and you will remain with this term, that is cos omega 0 n. So here we can substitute this value. Okay, so that is n is equals to minus infinity to infinity. So in place of cos omega 0 n, I can substitute this value, that is 1 by 2 e to the power j omega 0 n plus e to the power minus j omega 0 n, right, into u of n into z to the power minus n. Now again you can modify the summation limits. Instead of minus infinity, it will be 0 to infinity, because for negative values of n, u of n is 0, and for positive values, that is for n greater than or equals to 0, u of n is 1. So you can simply write it as what, it will be equals to summation n is equals to 0 to infinity, so 1 by 2 e to the power j omega 0 n plus e to the power minus j omega 0 n into z to the power minus n. You can separate these terms, right? So n is equals to 0 to infinity, so you can take 1 by 2. So here this 1 by 2 is constant basically, right? So e to the power j omega 0 n into z to the power minus n plus again it can be 1 by 2 summation n is equals to 0 to infinity will be there 1 by 2 e to the power minus j omega 0 and z to the power minus n. Okay, so again this 1 by 2 summation n is equals to 0 to infinity e to the power j omega 0 z inverse whole raised to the power n plus 1 by 2 summation n is equals to 0 to infinity e to the power minus j omega 0 z inverse whole raised to the power n will be there. So again, as per that infinite geometric series, you can write it as 1 by 2 1 upon 1 minus e to the power j omega 0 z inverse. Okay, plus here 1 by 2 again 1 upon 1 minus e to the power minus j omega 0 z inverse. Right? So this is the z transform of what? Cos omega 0 n into u of n. So we have to identify it for x of n, that is a to the power n cos omega 0 n u of n. Okay, so therefore the z transform, so you can say that as per time scaling in the z domain property, right, of z transform, the z transform of x of n can be indicated as capital X of z, and it will be z transform of this small x of n, and x of n is a to the power n e to the power n cos omega 0 n into u of n. Right, we'll have this z transform. Simply wherever there is z, you have to replace it with a inverse z. Right, so if I am replacing it with a inverse z, so here in place of z I will be getting a inverse z. Right, so how you can write it as 1 by 2 1 upon 1 minus e to the power j omega 0. Right, in place of z I will be substituting a inverse z, so in bracket a inverse z means, so minus minus will be plus, so it will be a z inverse simply. Right, plus again 1 by 2 1 upon 1 minus e to the power minus j omega 0, again in place of z I have to substitute a z inverse. Right, as per the scaling in the z domain property, so it will be again minus minus plus, so it will be a z inverse. Right, so as we have seen in the linear property, the ROC in this case, because these are two different terms, right, so this mod e to the power j omega 0 z inverse will be less than 1 in for the previous or the first term in this z transform, and for the second term it will be mod e to the power minus j omega 0. Right, that is the mod a less than 1. Okay, as per mod a less than 1, but in place of a e to the power minus j omega 0 z inverse is there, so e to the power minus j omega 0 z inverse less than 1. So simply z inverse if we are sending here, so it will be mod z greater than e to the power j omega 0 and mod z again greater than e to the power minus j omega 0. Okay, so this e to the power j omega 0 and e to the power minus j omega 0 is simply 1. Okay, so the ROC for the z transform of cos omega 0 n into u of n, the ROC for this is mod z greater than 1 simply. So therefore the ROC for x of z, okay, that is x of z, that is nothing but z transform of that is e to the power n cos omega 0 n into u of n. Okay, so the ROC for this will be simply in place of z you have to substitute what, A inverse Z. Okay, and if I'm sending A inverse on the right hand side, so it will be 1 upon A inverse, so it will be simply A, right? So mod Z will be greater than A. How it comes? So basically in place of Z I am substituting A inverse Z, right? So this mod A inverse Z will be less than 1, so it will be mod Z and 1 upon A inverse, so it will be simply mod Z less than, sorry, greater than, it is greater than sign, mod Z greater than A will be there, right? So this is the required ROC for that transform. Okay, as per the scaling in the Z domain property. Okay, so here we have applied the scaling in the Z domain property for identifying a to the power n into cos omega 0 n into u of n. In place of Z we only substituted a inverse Z, so it will be az inverse, and here also it will be az inverse, because a to the power minus 1 multiplied by a to the power, sorry, raised to the power minus 1 will be 1 simply. Okay, so again in this case even you can substitute the values of e to the power j omega 0, right? E to the power j omega 0 is cos omega 0 plus j sin omega 0. Here you can substitute cos omega 0 minus j sin omega 0, and after simplification, that is after addition, you can get this value. Okay, so what value you will get? So the Z transform of this a to the power n cos omega 0 n into u of n, its Z transform after simplification and after substituting the values of this e to the power j omega 0 and e to the power minus j omega 0 in terms of cos and sine, you will get this term. Okay, that is a, sorry, 1 minus a z inverse cos omega 0 whole upon 1 minus 2 a z inverse cos omega 0 plus e square z to the power minus 2. You have to add these two terms and you have to substitute e to the power. In place of e to the power j omega 0, you will substitute cos omega 0 plus j sin omega 0. And in place of e to the power minus j omega 0, you will substitute cos omega 0 minus j sin omega 0. And after addition, you will get this term. Okay, and this is the ROC for this. Similarly, you can find it for the second. Okay, second is given as x of n is equals to a to the power n sine omega 0 n into u of n. So again here you can directly write it down now. So again here you can identify initially the Z transform of sine omega 0 n into u of n. Okay. So again, as per the Z transform formula, you can write n is equals to minus infinity to infinity. Right. Here I can write sine omega 0 n into u of n into z to the power minus n. Correct. So again here I can substitute in place of sine omega 0 as per the Euler's identity. I can write n is equals to minus infinity to infinity 1 upon 2j e to the power j omega 0 n minus e to the power minus j omega 0 n into u of n into z to the power minus n, because e to the power j omega 0 n is cos omega 0 n plus j sin omega 0 n. It will be cos omega 0 n minus j sin omega 0 n. So minus minus plus will be there, cos omega 0 n minus cos omega 0 n will be 0. It will be 2j sin omega 0 n, 2j will get cancelled and you will get sin omega 0 there, right? So you can modify the limits here, right, of n. Instead of minus infinity, negative values of n will be eliminated, because for negative values of n, u of n is 0, so you can take it from n is equals to 0 to infinity. So it will be 1 upon 2j e to the power j omega 0 n minus e to the power minus j omega 0 n into z to the power minus n. Okay, so you can separate these terms. You can take n common, right? So I will write these here directly, so you will get simply 1 upon 2j n is equals to 0 to infinity e to the power j omega 0 z inverse all the rest to the power n, okay, minus again 1 upon 2j summation n is equals to 0 to infinity e to the power minus j omega 0 z inverse all the rest to the power n, okay. Again, as per this infinite geometric series, the final Z transform will be sine omega 0 n into u of n. It will be equals to 1 upon 2j 1 upon 1 minus e to the power j omega 0 z inverse, that is it is a to the power n, so it will be 1 upon 1 minus a, so in place of a it is 1 minus 1 upon 1 minus e to the power j omega 0 z inverse, right? Minus 1 upon 2j 1 upon 1 minus e to the power minus j omega 0 z inverse, right? So again, as per this infinite geometric series, you will have this e to the power j omega 0 z inverse mod should be less than 1, and this e to the power minus j omega 0 z inverse mod less than 1. Okay, so that means this will be simply mod z greater than e to the power j omega 0 and mod z greater than e to the power minus j omega 0. Okay. So again, this e to the power j omega 0 e to the power minus j omega 0 will be approximately 1. So the final ROC for this will be mod z greater than 1. Okay. So therefore, as per scaling in the z domain, the z transform of this x of z is equals to a to the power n sine omega 0 n into u of n, okay, will be simply here in this transform. Okay, you are multiplying it with a to the power n, and in z domain you have to replace z with a inverse z, okay, as per this property. Okay, z will be replaced with a inverse z, right? So here in place of z, if I am substituting a inverse z, so I will get a z inverse, right? Here also I will get a z inverse, okay. It will be 1 upon 2j, right? 1 upon 1 minus e to the power j omega 0 az inverse will be this, right? Plus 1 upon, sorry, not plus, it is minus. So minus 1 upon 2j 1 upon 1 minus e to the power minus j omega 0 az inverse will be there. Okay. Again, as per ROC, so z is replaced with this a inverse z, right? Less than 1, so simply, sorry, less than, it is greater than 1, so simply ROC will be mod z greater than a. Okay, if I'm sending this a inverse on the right hand side, so 1 upon a inverse will be there, so it will be a. Okay, so this is the required Z transform. Again, if I'm substituting these values here, that is the values of e to the power j omega 0 and e to the power minus j omega 0, right? So I will get some different terms there, okay. So you can find it here. So just for example, if I will substitute these values here, so x of z is equals to what I have, it is 1 upon 2j, okay. So I will take this 1 upon 2j common, so in bracket get 1 upon 1 minus, in place of e to the power j omega 0 I can substitute cos omega 0 plus j sine omega 0, right, into a z inverse will be there. Similarly, minus 1 upon 1 minus again c to the power minus j omega 0 will be cos omega 0 minus j sine omega 0, and again a 0 inverse will be there. So it will be 1 upon 2j. Okay. So I have to subtract it, so it will be simply in bracket 1 minus cos omega 0 minus j sine omega 0 divided by a z inverse minus, and will be this, right? This minus minus will be plus, then again in bracket cos omega 0 plus j sine omega 0 into az inverse will be there. Whole upon, to multiply this. Okay, so it will be simply 1 minus cos omega 0 minus j sine omega 0. I'm initially multiplying 1 with this complete thing, okay, into az inverse, right? Then I have to multiply it with this one minus cos omega 0, so it will be again minus cos omega 0 plus j sine omega 0 into az inverse, this minus cos omega 0 plus j sine omega 0 into az inverse multiplied by 1 will be this value. Again this minus minus will be plus, right? So I'll write here, so this will be cos omega 0 plus j sine omega 0, right, into az inverse. Again this will be multiplied with this one, that is cos omega 0 minus j sine omega 0 az inverse. Okay. So if you simplify this now, so x of z will be, so this 1 minus 1 will be 0, right? So this minus cos omega 0 plus cos omega 0 will be 0, right? So this minus minus will be plus, so this will be j sine omega 0, and this again plus j sine omega, so it will be 2j sine omega 0, and this az inverse will be as it is, okay, in multiplication, so it will be 1 upon 2j, that is az inverse 2j sine omega 0 will be there, right? 1 upon, so basically these 2j will get cancelled, right? So whole upon, so again in this case you can find here that this one will be as it is, that is 1 minus, okay? Again if you find it here, this if you are multiplying this term, so this a z inverse multiplied by a z inverse will be a square z to the power minus 2, right? And if you multiply these two brackets, right, that is cos omega 0 multiplied by cos omega 0, correct, then it will be cos square omega 0. Again it will get multiplied with minus j sine omega 0 into cos omega 0, so it will be plus j sine omega 0 plus into cos omega 0, right? So this minus j sine omega 0 cos omega 0 plus j sine omega 0 cos omega 0 will be 0, and then j sine omega 0 multiplied by this minus j sine omega 0. Okay. So again it will be j multiplied by j will be j square, and we know that the j square, that is imaginary value square, will be minus 1. So minus minus plus will be there. So it will be cos square omega 0 plus sine square omega 0. So it will be 1 simply. Right? So this whole will get reduced to simply a square z to the power minus 2. Right? And then if you add these two terms, so it will be simply what? Uh, Minus cos omega 0 minus cos omega 0 will be minus 2 cos omega 0, right? And then this will be minus j sine omega 0. The minus minus plus will be there, but here it will be minus j sine omega 0, so it will be 0. Simply I will get 2 into this a z inverse will be as it is. This is a multiplication. So 2az inverse will be there into cos omega 0 will be there, right? And this minus j sine omega 0, it will be plus minus j sine omega 0 az inverse, it is minus j sine omega 0 az inverse will be 0, and then finally this will be the reduction of this term, that is minus 2 az inverse cos omega 0 will be there, and plus, so this whole term reduces to only the multiplication of these two terms, that is a square z to the power minus 2. Okay. So the final z transform, when you simplify it, so it will be simply az inverse sine omega 0 upon 1 minus 2az inverse cos omega 0 plus a square z to the power minus 2. Well, so this is the required z transform. Okay, after simplification, and ROC for this was mod z greater than e. Okay. So this is how you are using the scaling in the z domain property. Okay. So if x of n has the z transform x of z, then a to the power n x of n has the z transform x of inverse z, and the ROC will be modified likewise. Right? So in this example, initially we identified the z transform of cos omega 0 n into u of n and sin omega 0 n into u of n, and by using scaling in the z domain we identified the z transform a to the power n cos omega 0 n u of n and a to the power n sin omega 0 n u of n. Okay. So you can keep this answer up to this step also, right? Or you can simply by substituting the value of this e to the power j omega 0 and e to the power minus j omega 0, and after adding we will get this value. Okay, after simplification. So similarly we have done the same thing in this case. Initially we identified the z transform sin omega 0 n into u of n. Okay, and then you have multiplied it with a to the power n to get the z transform. Okay. So z transform a to the power n sin omega 0 and u of n is simply, here we are replace z with a inverse z. So here we will get a z inverse, right? Then we have substituted the values of e to the power j omega 0 and e to the power minus j omega 0, and we have simplified it, and after simplification we get these values. Okay. So in next session we'll be discussing another property of z transform, that is time reversal property. So thank you for joining this session.